Okay, up next we have nitrogen oxides, NOx. Okay, so MARPOL Annex 6 Regulation 13, nitrogen oxides, applies to marine diesel engines with a power output of more than 130 kilowatts. So not applicable on engines intended for emergencies. Tier 1 vessels built between January 1, 2000 and January 1, 2011. Tier 11 vessels built on or after 2011. And Tier 3 vessels operating in NECA from date of adoption. So here are the NOx limitations for Tier 1, around 17 grams per kilowatt hour. For Tier 2 engines, around 14 point something, 14 or 14.5 maybe. And for Tier 3 NOx emission control areas, NECA areas, so we have 2.7 or 3.5, I'm sure this one. So that's, and going downwards to depending on the rated engine speed or RPM. Okay, so what are the emission control areas for our MARPOL Annex 6 air pollution emission control areas? We have the Baltic Sea for SOx and NOx. We have the North Sea for SOx and NOx. North America for SOx and particulate matters and NOx. And United States Caribbean Sea for SOx and particulate matters and NOx. So creation of NOx. So 80% volume per volume of the air consists of nitrogen gas. So 80% of the volume of, actually that's round up to 80%. So nitrogen concentration in HFO max is 1% mass per mass. So nitrogen oxides when temperature is over 1600 degrees Kelvin or 1873 degrees Celsius. So nitrogen oxides are mostly produced on temperatures over 1873 degrees Celsius. So nitrogen oxide plus oxygen oxide is equal to 2NO. So part of NO is transformed during the expansion phase in nitrogen oxide and nitrogen, what's this, nitrite. The level of NOx emissions is mainly governed by the design and operation influencing the combustion temperature. So they are looking at the combustion temperature of our engines not to exceed 1873 degrees Celsius to reduce the NOx emissions on ships. Okay, so problems caused by NOx. So NOx causes smog, smoke and fog. It's a smog. NOx contributes to the formation of acid rain as it reacts with H2O and becomes nitrate. So nitrate is an important nutrient promoting the growth of organisms such as algae. So it creates toxicity and a lack of oxygen in the water needed for fish and shellfish to survive. So it's dangerous to our marine life. Development for marine diesel engines. So high power output per cylinder. So they have increased the power output to reduce NOx. Compatible for low grade fuels. Reduction of specific fuel oil consumption. Optimizing of concepts and materials to reduce maintenance and number of components. Increase of overall efficiency of installation. So one of the ways to decrease is to increase high power, the power output. So to increase the Pmax, it is also going to reduce the SFOC. So increase of Pmax causes increase of indicated pressure. So thermal efficiency is equals to indicated pressure over the mass will increase. So when the mechanical efficiency stays the same or even increases, the total efficiency will increase. So this will give a reduction of the SFOC. Following SFOC is equals to 1. So another method is to increase the Pmax is to put anti-polish ring. So the smaller the area, the higher the pressure that it will be produced during combustion. Effect increased Pmax on NOx emission. So to increase Pmax ignition before top dead center and most of the combustion just after top dead center. So during ignition and early combustion, temperature and pressure are high and the high concentration of oxygen gas is present. So result, high NOx formation. So how will they deal on this? So reducing NOx emission. So retarding of injection 5 to 10 degrees will cause ignition after top dead center. So as a result of expansion, temperature and pressure are lower, which gives strong reduction of NOx formation and increase in SFOC and thermal load on the engine component due to more after burning. So let's compare. This is the maximum firing pressure, pressure rise induced from combustion, pressure rise induced from compression. So for engine maximum firing pressure, so for low NOx combustion, this is for the conventional combustion. For low NOx combustion, cylinder pressure is here, pressure rise induced from compression, and the pressure rise induced from combustion is here. So low NOx combustion. So they are retarding injection, will cause ignition after top dead center. So they are delaying the injection. So modify high pressure fuel system. Use a very high injection pressures. So 2000 to 3000 bar. So independent control of start and stop of injection to control ignition and combustion during complete power range and independent of fuel oil quality. So other type of fuel injection nozzles. So you can also increase the injection pressures 2000 to 3000 bars. So we have here a fuel pump. So this pumps fuel here into the injector at 1000 to 2000 to 3000 bar pressure. Modify high pressure fuel system. Electronic controlled fuel system has possibility to have double injection resulting in lower max combustion temperature, less NOx formation. First injection just before top dead center. Second injection stops at plus minus 21 degrees after top dead center. So they have double combustion. So double combustion, lesser Pmax. So lesser Pmax, lesser temperature, lesser NOx formation. Another one, we have the Miller cycle. Intake valve is closed faster. Intake air is expanded. Temperature decrease in the cylinder. And then compressed air, reduced compression temperature. Reduced air temperature before combustion, decreasing NOx. So another way is closing intake valve before bottom dead center. So before bottom dead center, intake valve is now closed. Expansion lowers temperature. Reduction of NOx by 30% requires increased charge air pressure. So they are increasing the inlet or the compression pressure to lower down the NOx. So Miller inlet valve, exhaust valve, NOx emission. So 30% reduction of NOx. Okay, so as you can see here, intake goes down, compression, combustion, power, exhaust. So there is a drop in air temperature in cylinder at the end of compression. Drops. Air inlet valve closing time. Another way to decrease NOx is using two-stage turbocharger creates higher boost pressure to achieve required air supply. Next, we have charge air humidification. So injecting water injection of 130 to 135 bar after the turbocharger. So air is cooled down by water drop water mist. So the air is cooled down, going to another cooler. So heat from cooling water is reduced. And then non-evaporating water is captured in the water mist catcher and recirculated. So there is a water mist catcher here so that the air will be saturated air will have its max moisture, will lessen their moisture or humidity. So water is injected in the air for cooling and making it saturated. Humidification of the air is controlled by maintaining the scavenged air temperature between 40 to 70 degrees Celsius. Water in saturated air reduces the peak pressure as water. Peak temperature as water has a higher heat carrying capacity than air. So around 60% NOx reduction is achieved by this method and Tier 2 can be attained. Tier 2 pa lang, so not yet Tier 3. Grabe. We have also another method, water in oil emulsification. So in our ship, they use homogenizer. Homogenizer is the one that will mix water and fuel. So it will be it looks like a blender. It will be mixed properly. So introducing water into the fuel lowers the combustion temperature due to water evaporation. So by evaporation of the water, the surrounding fuel is vaporized, increasing the surface area of the fuel. So a lower temperature and better fuel distribution are leading to a lower formation of nitrogen oxides. Okay, so this is an example of water oil emulsification. We have here the fuel water emulsion control here, also known as homogenizer on other ships like the MAN BMW engines. And then water here is injected into the fuel and then they are emulsified or mixed together so that the fuel during combustion will create lower temperature during combustion. Next, we have direct water injection. So water is fed into the cylinder head at high pressure, 210 bar. The flow fuse acts as a safety device, shutting off the water flow into the cylinder if the water needle gets stuck. Water injection timing and duration is electronically controlled. Direct water injection can achieve 50 to 60% NOx reduction, attaining Tier 2. So we have here an injector for the fuel and another needle for the water. So this is a dual nozzle injector, one for water and one for fuel. Okay, next we have the selective catalytic reduction, SCR. So here exhaust gas enters into an area where urea is injected, urea injection, go into a flow mixer, and then we have here catalytic elements and the exhaust gas out. So SCR converts NOx into nitrogen and water. So urea which have NH2 2CO solution is injected in the exhaust gases. So the use of a catalyst, ammonia NH3, is created that reacts with the NOx. Then it is converted to nitrogen, gas, and water. So we have here exhaust gas, NOx, and then combined with NH3, we have here a urea solution, 40% urea solution combined with NH3 will be produced, and then the SCR reactor will change the outlet of the exhaust gas to nitrogen gas and H2O. So water will be removed and nitrogens will go back to the atmosphere. Here nitrogen oxides go, but the NNO, the nitrogen oxide, NOx, nitrogen dioxide, is trapped into the SCR reactor. Okay, so if this is your engine, we have a pumping unit for the urea. exhaust gas goes through the mixing injection unit and then goes to the reactor, and then with soot blowing unit for cleaning, and the NOx will be reduced. So another one, all the diesel has their own SCR, selective catalytic reduction, before going to the scrubber for sulfur oxide reduction naman. So operation of SCR, for effective operation, the minimum exhaust gas temperature should be around 300 to 360 degrees Celsius. So at lower temperatures, NH3 slip and reaction with SO3 can occur. So in two-stroke engine, the exhaust gas temperatures may be too low. So SCR is placed upstream of turbocharger, high pressure. SCR is placed after turbocharger, low pressure. Urea is used in marine application due to safety, health, and environmental hazards of NH3. Urea is mixed with fresh water before injection. With the use of SCR, tire 3 can be attained. So tire 3, grabe. So minimum exhaust temperature required at SCR inlet to avoid ammonia sulfate formation, SO3. So this is the temperature, not exceeding 350 degrees Celsius. So tropical condition, 45 degrees Celsius suction air temperature, exhaust gas temperature. Operating range with increased urea consumption, optimum operating range. So here, so around 350 to 400 degrees Celsius. We have high pressure SCR. So after the engine, we have here a exhaust gas receiver. After the exhaust gas receiver, we have a reactor, sealing valve, compensator, vaporizer or mixer, and then going to the SCR. After the SCR, goes to a valve and can also be used back to the scavenge air receiver, or going back to the turbocharger. High pressure SCR. Low pressure SCR. So from the engine, exhaust gas receiver, going to the turbocharger, and then a valve before reactor, mixer, SCR, reactor, and then going back here and going up. Let's go back to the high pressure. From the exhaust gas receiver, exhaust gas can be moved to the SCR reactor, going to the turbocharger, and then going to the funnel. So this is for high pressure. So exhaust gas is treated first before going to the turbocharger. While for low pressure SCR, exhaust gas goes to the economizer, exhaust gas boiler, before going to a SCR reactor and going to the funnel. Or you can use the turbocharger. From the exhaust gas receiver, going to the turbocharger, going to the reactor, SCR reactor, and then going to the funnel. So that's the difference of the low pressure and high pressure SCR. Okay, selective catalytic reduction for Kongsberg. So this is the SCR reactor. Exhaust gas goes here, going to the reactor, and the controls with ammonia tank, urea. Okay, so selective catalytic reduction. Another picture of the SCR from the main engine, going to the turbocharger, and to the exhaust with, what's this, analyzer, exhaust gas analyzer, smoke meter. So where is the ammonia cylinder here? Going into the, so the ammonia is injected into the inlet. Well, another design. Exhaust gas recirculation. So another another way to decrease the NOx is using the exhaust gas recirculation. So the majority of nitrogen monoxide is formed thermally at a rate that is mainly dependent on the temperature during combustion. So thermal NO formation is significant at 1200 degrees Celsius and rises exponentially above 1500 degrees Celsius. So the amount of oxygen gas available and the time the combustion gas is exposed to a sufficiently high temperature are important factors. So EGR lowers the O2 content and increases the heat capacity of the charged air. The mixture of fresh air and recirculated exhaust lowers the peak combustion temperature, resulting in lowering the formation of nitrogen oxides. With EGR, Tier 3 level can be attained. Grabe. Tier 3. So this is an example of an EGR. So after the turbocharger, part of the exhaust gas will go back, retreated, cleaned, and going back to the EGR, going into the scavenge manifold. So this is an EGR. Let's go look at the engine. So air, fresh air enters the scavenge air, and then exhaust goes up, and then recirculated exhaust gas goes to a pre-scrubber for cleaning, other scrubber, and then going to back to the cooler into the inlet to the charge over valve for mix cooler. So that is EGR. So we have IAPP certificate for this from the ship. So International Air Pollution Prevention Certificate, Engine International Air Pollution Prevention Certificate. Okay, so if you are approved for Tier 1, Tier 2, or Tier 3. So NOx technical code. A technical file is a record containing all the details of parameters, including components and settings of an engine, which may influence the NOx emission of the engine. So components are those interchangeable parts which influence the NOx emission performance identified by their design parts number. So you can see everything here in the NOx technical code. So this is another. So in the NOx technical code, you can see these details. If this is verified for NOx verification procedures. Okay, so that's it for our NOx. So there are many technologies that are used to decrease the NOx emission on ships. So those are the innovations that are used on board ships. So that's it for our part 2 of our video on innovations in protecting the innovations in decreasing air pollution. So that's it. Thank you for watching, and I hope you learned something today. So our next video will be more on the carbon capture and storage system, which is a new technology used on board. This technology is already used in land for how many years, and now there is a chance that it will also be used in our ships. So I'll see you on our next video. Thank you. Please do like and subscribe our channel. Thank you and goodbye.